Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on reservoir simulation using tNavigator. And we are going to use example case from tNavigator. Today's topic is about reaction. We will have reaction, but the application of this reaction is actually to inject chemical tracer from which we can infer the residual oil saturation, something like that. I will not talk a lot about the theory behind the reaction, behind the tracer itself. I just will show you what will happen in the reservoir, in the data set, in the scripting, something like that. Okay. And maybe for myself, the main point here is to show you that we can exercise reactions in reservoir simulation. Okay. So this is our model. It's quite a simple model. Let me change the direction first. Click on this, flip vertically. So that direction points to the north. As usual, we are currently looking at the pressure in 2D map. Let's check the 3D map. Okay, so it's like this. And then let's check the initial properties, block X, Y, Z. And you can see the difference here. It's because we have LGR, local grid refinement, right? Like this. Block X, Y, Z, the depth. Okay. And then tops net to gross porosity, permeability along X, Y, Z aquifer. Okay, so we have bottom aquifer, but from the edge, right from that side. And if we go to 2D, can we go to average? You see, so this is the direction from which the aquifer water will encroach into the reservoir. And then again, the pressure. So from that side that is connected to the aquifer will have, of course, the higher pressure. Saturation of oil, so we have a good saturation there, especially at the top of the reservoir. Water, gas, ternary, and then other properties. Okay, and you can see here, this is a calculated model, and we have many components. Basically, it's a compositional modeling. We have for water, alcohol, acid, ester in aqueous phase, C1, hydrocarbon C2 and C3, C4 and C6, C8, and ester again, but this is the hydrophobic. This is the ester that has connection with the hydrocarbon, but this one ester site that is going, that is connected to the aqueous phase. So ester has two connections. With one is hydrophilic, which is aqueous, and hydrophobic. So it will tend to the hydrocarbon. Okay. And then fluid in place, water in place, oil in place, vaporized oil in place, free gas in place. Regions, let's see. We have only one PVT region. Okay, good. Saturation region only one. Rock compaction only one. Equation of state. So all of which have only one region. Okay. Okay, no specific regioning. Okay, good. User cut, no. User map later. Oh, we will not use user map. Okay, so that's it. That's it for the model, introduction. And let's open the dataset. Okay. All right. So of course we open with run spec and title, and then I put it here, the description, so you can read it with me. So now we will have single well chemical tracer test. This is a quick method of assessing the residual oil saturation. Ethyl acetate ester is injected into the reservoir in a mixture with water. Okay, so ethyl acetate ester with water. Over time, the ester partially undergoes hydrolysis and turns into ethyl alcohol or ethanol and acetic acid. That's why we have component called alco, which is for alcohol, and acid, which is for acetic acid. And then ethanol mostly resides in the water phase, yeah, while the remaining ester is distributed between water and oil phase. After some time, the same well turns from injection to production. Ester and ethyl alcohol or ethanol are monitored in the produced fluid. Due to the different phases distribution, the production of ester and ethanol peaks at different times, from which the residual oil saturation is deduced. Okay, so actually in the example given by tNavigator, there will be calculation from which we can calculate the residual oil saturation from the difference of peak time between ester and ethanol production. But I will not explain about that. Okay, we'll just show you the mechanism of the coding of the simulation behind whatever it is about the scripting. Okay, not about the physics of what really happened in the reservoir. All right.